Hello and welcome to BeginPlay, an Unreal Engine onboarding for developers. My name is Sebastian Hernandez, I'm an evangelist for Unreal Engine, and today we're going to go over blueprints and visual scripting. Since its earliest versions, Unreal has always supported in-editor visual scripting with the goal of making the development process as flexible and easy as possible. This has proven to be so powerful that over time it's evolved into a complete scripting toolset, to the point that you can build entire games with great performance without having to write even a single line of low-level code. Each major release brings visual scripting to even more Unreal Engine workflows. One of the main things to keep in mind is that visual scripting is not just for programmers, and it pays off for your entire team to understand its core concepts. Plus, it's a lot of fun to learn and use. Also, since you have access to the entire engine's source code, it's completely possible to build your own visual scripting tools or expand existing ones to fit your needs. Because of this, we recommend that everyone in your team makes an effort to learn visual scripting, even the non-technical team members such as artists, audio designers, and quality assurance. If you're a coder, you should aim to empower your team by exposing useful functionality to Visual Script whenever it makes sense to do so. Here's a quick overview of the visual scripting schematic. Everything is ultimately based off of C++, and you can find code equivalents to all the visual scripting functionality in the engine's source code. These tools provide an access layer between the engine and all the low-level functionality, with a ton of features built around it. In most cases, these assets are compiled to bytecode and executed by a fast virtual machine, minimizing the performance footprint. There's a growing number of editor modules that make use of these features, from basic gameplay to user interface, animation, and AI. Blueprint also acts as a communication layer between many of these asset types, and it's important to understand the implications this has on asset loading and memory usage. Over the next videos, we'll cover each of these subjects in greater detail. Real tools and workflows that make use of visual scripting. The most common of these are the level and actor blueprints, which help you build gameplay logic both visually and with a fast iteration cycle. Each map has its own level blueprint for specialized behaviors, and you can use blueprint assets to extend most of the core engine classes or build your own custom types. Next up is Sequencer. Although it's mainly a linear animation and cutscene tool, you can define event tracks within your sequences and invoke blueprint code at specific times in your animations. Speaking of, we also have animation blueprints. These work along with skeletal meshes to provide powerful animation playback and blending support, with immediate feedback and without having to rely on the coding team. There's also Unreal Motion Graphics, or UMG for short. It helps you build complex game UI and handle its update and interaction logic. Niagara is Unreal's new simulation and VFX framework. In addition to its hefty feature set, it provides its own visual scripting language to create new data processing nodes and empower your team to create custom effects. Because of Niagara's reliance on parallel execution, some limitations apply, and for the most part you can't loop or branch code within your custom Niagara modules. The Variance Manager provides a way of defining and applying property sets in a simple way without the complexity overheads that come with having tons of slightly different actor types. You can use blueprint code to switch these variance sets on or off. Behavior trees and environment queries work closely together to create and fine-tune AI behaviors. Behavior trees define the order and priority of your AI decisions through a visual graph, and EQS enables you to sample the entire level for the optimal location for your AI entities to achieve their goals, be it finding the perfect sniping spot or the nearest health pack. UE5 introduces meta sounds, a new way of building complex audio effects through visual scripting. Not only is meta sounds fun to use, but it's also incredibly fast, efficient, and sample accurate. Last but not least, Mass is a powerful new UE5 toolset that brings you the ability to execute and coordinate behaviors for very large numbers of game entities. It uses a visual editor to build and manage task lists to apply to these entities. All visual scripting functionality is rooted in C++. Most Blueprint exposed engine classes can be extended through inheritance. Both C++ native subclasses and Blueprint-only types are supported. Blueprint is a strongly typed language. It prevents you from storing data in unrelated variables. This makes it much safer than other commonly used game scripting languages. It's easy to expose C++ functionality to Blueprint, including variables, functions, and even complex types such as strings and data structures. At the same time, sending data to C++ from a Blueprint source is fast and seamless. Blueprint also supports network replication out of the box, especially when using gameplay framework classes as a project template. This makes it possible to build entire multiplayer games extremely quickly. The engine also provides data features that make it easy to separate Blueprint code from its data and empower your game designers and balancers. These include data tables, curves, and other data assets. Curves can be created from the content browser and shared between multiple blueprints. They are a great way of encoding and sampling data in function of a value, such as damage over level or jump height over ground speed. Data tables are similar to built-in spreadsheets. You define a data structure to act as your column template and add as many data rows as you want. You can then easily retrieve data rows through code. You can import table data from an external spreadsheet file or export it to either CSV or JSON format. There's also plenty of other specialized data assets, and it's easy to extend or create your own, giving you all the benefits of Unreal's asset management system while keeping fast-changing game data separate from your code. Now let's delve a little deeper into the Blueprint editor. Most Blueprint assets provide a set of one or more graph tabs and a set of related data. This data includes all the variables and functions that make up your blueprint, but may also include event dispatchers, components, and macros. Some blueprint types, such as widgets and actors, also include a viewport or design view. You can use it to preview and edit the appearance of the resulting object without having to constantly run your application. Most of the actual coding happens in the graph windows. You can either drag elements from your blueprint data or right-click and search for functionality. Then you connect the nodes to build your code flow. In addition to variables, actor blueprints can also hold a hierarchy of components. Components are specialized sub-objects that perform a specific task, such as rendering a mesh, playing a sound, or managing the pathfinding and movement of your actor. There's dozens of component types available out of the box. You can build your code using 3 different types of execution units: functions, events, and macros. Functions are very similar to their C++ counterparts. They can receive arguments and return values, and they always execute their code in the same frame you call them. Events are a bit more flexible because they support asynchronous execution. You can call task nodes that sit around waiting for stuff to happen, then continue their execution flow without all the complications of building async code with low-level programming. As a trade-off, events can't return values. Macros are nothing more than a grouping of nodes. When they compile, blueprints automatically expand them to their full form. One neat feature of macros is that they support multiple output execution pins, making them ideal for neatly representing branching logic. In fact, a good deal of the core blueprint functionality was built using macros, and you can view it by double-clicking on any node with a gray title bar. Timelines are a powerful feature of actor and level blueprints. These are a collection of curves that can be played, stopped, and reversed at runtime. As long as they're playing, they report back the values of all the curves at their current time. Timelines are incredibly useful for building simple animations and time-based transitions. Next, let's go over some of the more useful advanced features of blueprints. Child actors provide a quick and convenient way to dynamically spawn and attach one actor to another. You can use them for weapons and other attachments, but also when you need actor-level functionality that behaves like a component. Speaking of components, you can create your own component classes either in Blueprint or C++, and they will be added to the Add Components dropdown. There's two important component types that serve as a good basis for subclassing. Scene components have a transform, and they can be attached at any point in the hierarchy. Actor components are more abstract and are meant to hold modular scripted behaviors that can be shared between arbitrary actor types. You don't always need to extend an existing Blueprint class to add functionality to your project. Function and macro libraries exist independently of a class and can be freely referenced throughout your code without the limitations of object inheritance. They can be especially useful for working with native data structures, which otherwise don't support Blueprint code. You can even use blueprints to extend the editor and automate common tasks. Editor utility widgets use Unreal Motion Graphics, the same tool you use to design your game UI, but they can be opened from the editor to provide custom editor utility windows. Action utilities can extend your right-click menu and perform tasks over an object selection set either in your level or the content browser. Finally, editor utility objects run passively in the background, listening for editor events. They are a great way of implementing asset validation checks for your designers and content creators. We should talk about the importance of visual scripting, communication, and referencing. All visual scripting assets are considered content instead of regular source code. This means that Unreal subjects them to the same loading and referencing constraints as any other engine asset, such as a mesh or a texture. By default, anything referenced by a variable or a visual scripting node will be loaded into memory whenever the referencing asset is loaded. Depending on the number of references, this can cause framerate hiccups or increase your memory usage. It's very easy to audit an asset's references and memory footprint through the reference viewer and size map tools, available from the right-click menu on the content browser. You can defer some of the loading by using soft reference variables instead of the default hard references. This will not load the asset automatically, but you need to explicitly do the loading process yourself before you can use the data. Inheritance is another common cause for unnecessary referencing. Each child class will reference its parent all the way up the chain, including any assets they reference, even if they've been overridden. It's a good idea to keep the asset references in your base classes to a bare minimum. This includes their components, so make sure to leave things like static meshes and Niagara emitters unassigned everywhere except in the leaf classes of your hierarchy. Typecasting is another case where you can end up with an implicit hard reference to a class. This one tends to be very common in collision detection and raycasting. There's a few approaches you can take here. One is to move all the core functionality to a base C++ class. C++ code is both fast and reference light, and it will be loaded as soon as your application launches. The second approach is to use an interface. This defines a set of functions that can be used to talk to the blueprint. You can call these functions instead of casting to a full class. The asset will only reference the lightweight interface and will fail gracefully if the object doesn't implement it. Finally, there's event dispatchers. These reverse the relationship, allowing your objects to subscribe to a predefined event and have one of their functions be called when the dispatcher is triggered. Now let's go over some of the most commonly used performance and debugging tools used with Blueprint. The most basic of these is the print node. It supports both on-screen and log printing, and because it's flagged as a development-only node, you have zero risk of it ever making it into a shipping build by accident. Whenever you test your game in Pi, you can use the Blueprint Editor window to select any instance in the level and visualize its code execution in real time. When a node gets executed, it will light up for a few seconds. You can also hover over individual pins to see their values and set watches. If you need more in-depth debugging, you can set up breakpoints on any execution node and then step through the code at your leisure. The Blueprint Debugger window also includes a call stack and watch variables view. There are times when just stepping through the code won't provide enough context. This is when the visual logger comes in. It enables you to record events into a timeline and later play them back at your own pace. You can also attach visual information to an event, from simple shapes to full actor state snapshots. It's even possible to write entire unit tests in Blueprint and have them run and validate through Unreal's automation framework. And as we saw in the engine overview, you can use the Unreal front-end application to manage remote debugging sessions and connected devices, which helps a ton when porting your game to additional platforms.